Jim, as the designer of the Micromoog, what was your basic design philosophy for the instrument?
The original intent was to build sort of the minimum system, minimum useful system, smallest synthesizer that we could. We were aiming for a low-cost instrument that was musically useful and reliable too.
There are generally three types of engineering which must be taken into account when building a musical instrument. First, and probably most important, musical engineering, or how the instrument interfaces to the musician. Then, of course, there's electrical engineering having to do with the circuitry of the instrument, and mechanical engineering having to do with the package and reliability of the instrument. Why don't we talk about each one of these a little bit? First, musical engineering. You once told me that the left-hand controller, the pitch ribbon and the modulation wheel on the Micromoog, was one half of the Micromoog. What did you mean by that?
By that I meant that by these controls, the musician can really get at the machine, the synthesizer itself. Any synthesizer has an awful lot of sound producing, music producing capability. But you've got to provide ways for musicians to get at it, to get their hands on it, to get their feet on it or whatever, for real, true musical expressiveness.
The use of the ribbon. Why is the ribbon unique? We had with the Minimoog the wheels, and with the Sonic 6, again, a wheel for pitch bending, but what will the ribbon give then?
It's just a lot more playable. It's a lot faster, and because it's like bending a guitar string on the ribbon. When you move your hand up the ribbon, your pitch changes. When you take your finger off it, immediately the synthesizer springs back to your keyboard pitch.
So we have an electrical return to the center pitch or tonality rather than a mechanical return, which requires time.
Right. There's a zero mass system or a zero reflex time or return time.
Now, the wheel on the Micromoog has been expanded in its use beyond that of what the Minimoog was to include a lot more functions. Would you comment on that?
It's just a matter of realizing that there's an awful lot you can do with a wheel besides what we've done in the past, and it's just organizing your synthesizer, the modulation section I'm speaking of here, so that we can do an awful lot with the wheel. I mean, it's just a matter of being careful when you design things.
What about the layout of the controls on the Micromoog, the use of the kinds of controls and how they are assembled, the human engineering as it's called?
It looks deceptively simple now when you look at the machine, but an awful lot of thought went into that. And we went through numerous revisions. A couple of days ago, I was looking through my files, and I found piles of front panel layouts where we went over and over and over and over again until we got something that I'm sure we really like, and I'm sure musicians will probably not appreciate it, really, at least not immediately. The simplicity of it is a little deceptive.
But the use of the left hand, of course, not only for the left-hand control section, but for roving over the control panel, if you will.
The way the panel was laid out was that the controls that you manipulate most while you're playing, these are panel controls, are over near the left side of the instrument, so they're readily reachable. You don't have to reach all the way across the keyboard to get your hands on the controls that you're most likely to use during playing.
What about the use of rotary pots? Some people say they're not as visible. Why does Moog continue to use rotary pots on their instruments?
Well, first of all, I hate sliders. Personal prejudice, but for darn good reasons. Whenever I use sliders, I'm frustrated. I don't like them. Mainly it's a setability problem. When you're moving a slider up and down, you have to use your whole arm. And somehow, to me, visually, I can, just seeing where the slider is set, I think I can tell a lot better where a control is set by looking at a rotary knob where you're dealing with angles, rather than looking along a slot and trying to guess where the slide knob is along the slot someplace.
What about relative maintenance problems?
Well, sliders generally aren't as reliable because they're susceptible to having crud falling in them, and they're mechanically have a tendency to be broken. The shafts have a tendency to be broken off too. They don't feel too good either because usually the shafts are kind of flexible. They bend and push from side to side. Okay. It's detriment.
Okay, we've talked a little bit about what's important to the musician, how he puts his hands on the instrument and what he can get out of it. Why don't we talk now, though, about what's important to the engineer, the electrical circuitry. This is a modest price synthesizer, but won't many people think that shortcuts have been made with the circuitry to achieve that modest price?
Absolutely not. The circuitry, we didn't make any compromises on the circuitry. That is where it was a possibility of saving some money by using a circuit that may or may not work. We just didn't do it. We took a little more expensive, sort of dumb approach. Did things in as simple a fashion as possible in a circuit to achieve reliability and also to achieve easy maintenance and tunability, and it's the circuits are reasonably understandable to a competent person, not tricky.
What about the stability of the circuitry?
It's extremely stable. That was a primary consideration in the design, and we did things like using custom resistor networks for matching a lot of resistors together so that the pitch remains very accurate. The octave clicker for changing ranges is extremely accurate and stable, and things like this were done throughout. And we used some new designs in the oscillator circuit too for a heated chip inside for rock stable pitch. Yeah.
This oscillator stability with the chip that heats, is that a new technology?
Yes and no. A similar type of circuit was used in our Sonic 6. It's been used for several years. But this particular circuit design is different in implementation in the Sonic 6, and it is a lot more accurate than previous designs. I don't know if anybody else is doing it, but I don't know everybody else's circuitry either.
Is temperature regulation, then, was what we're talking about, the same as compensation, as some other manufacturers have done?
Yeah, you have a choice of compensating or regulating, either compensating the oscillator for changes in temperature or regulating temperature. In the past, most of our circuitries employed a compensating circuit for temperature changes, whereas in this one, we completely avoid the problem by fixing the temperature.
So the oscillator then just doesn't sense what the outside temperature is because the temperature within the oscillator is so hot.
Yeah, technically, it's just one little critical portion of the oscillator. That's the temperature intensity portion that we heat. The rest of the oscillator is whatever temperature the room is.
Well, we've talked about musical engineering, and we've talked about electrical engineering, and I suppose the last thing to talk about is mechanical engineering. With musical engineering, that means, is it a musical instrument and can it make music? Can I play it? Can I get my hands into the music? Electrical engineering means, is it electrically stable and accurate? The mechanical package, however, is important because once you go on the job, is the instrument going to hold up?
This particular problem was extremely important consideration when we were designing it. The Micromoog is the most rugged and reliable synthesizer that I know of. It's either ours or our competitor, either our old instruments or our competitors' instruments. Not only that, but it's been designed aesthetically to look for a very pleasing appearance. It looks like the high quality piece of equipment that it is.
What about the recessed panel controls? What was the reason for that?
Basically, we had to make the instrument bash proof. We know that typical user will be a rock musician who's on the road and their equipment just gets beat to hell. Heck. So we tried to protect everything as much as possible. So we recessed all the knobs and the keyboard and the stuff, the input and output jacks and switches and things on the back. Everything is recessed so you can roll this instrument completely upside down, or you can drop the thing. We've done some experiments where we've dropped a fully functional Micromoog several feet on a concrete floor 2 or 3 times, and we managed to crack the ends after doing it a couple of times, but the machine was still completely functional. It didn't hurt anything.
Right.
Still ran.
What about service? Often if a musician gets out on the road and experiences a service problem, how difficult would it be to get into the Micromoog and fix the problem?
Oh, it would take them 2 or 3 minutes with a screwdriver to get the thing apart. That was, again, something we were very careful about in designing it, is to make sure that you can get the thing apart and get at it if necessary. Also, the circuit boards in it are pluggable. They can be replaced easily, which simplifies service an awful lot. Not only on the road, but if it comes back here for service and is a tricky problem or a dog board that just somehow won't work at all, it's only a matter of, again, a few minutes to completely replace the synthesizer, which is the main board. It's the whole synthesizer.
You mentioned a while ago jacks and plugs in the back of the instrument. What are those used for?
So those inputs and outputs, if we're going to use engineering terms, are there just to extend the usefulness of the machine. The simplest thing is to attach foot pedals to it so you can manipulate 2 or 3 of the front panel controls by foot, essentially. But there's a lot more beyond that, because using these inputs and outputs, you can interconnect several synthesizers together. A simple example would be to gang together 2 Micromoogs and play them both from the same keyboard. And there are a lot of other very nice little things you can do just by having all that available.
Such as accessories?
Oh, yeah. All the Moog accessories will plug into the back and can be used to sample and hold the ribbon. Although that's not too useful because there's a ribbon on the micro. And especially the percussion controller. can be used with it.
As an engineer who's had some experience designing musical instruments and some musical background yourself, what do you see to be the important things for the musician to look for when he's evaluating a synthesizer for performance use?
It's got to be non-confusing. It's got to be easily settable. You got to be able to glance at the panel and make changes, and you've got to have the layout or the panel layout of the thing organized in such a fashion to avoid traps, pitfalls. The funnies where you set this knob that way, that knob the other way, and the switch over there, and nothing happens, or it howls at you, or it blasts your amplifier off the off the stage or something. That was one of the guiding principles in this thing. It had to be. In the heat of battle, there's not an awful lot you can do, not an awful lot of changes that you can do on a complex machine. The most important thing is the sound. It's got to be clean. It can't be any noise and hash and stuff sneaking through. And beyond that, it's just got to sound good. And what it is to make an instrument sound good well, if an instrument sounds good or not, it's up to the musician, really, his own ear. We've used proven circuit techniques we've used for years and years and years, some of which we're really not too sure why they sound good, but we're sure as heck not going to change it.